In our last video, Solving Rational Equations Part 1, we looked at what a rational equation looks like, and we looked at the process for solving them. I have those listed here. Those are explained more fully in the video Part 1. And we did a couple of equations, solved a couple of equations. Now we're going to look at one that's a little bit more challenging. Excuse me. And has a couple of extra things that I wanted to point out. So, as always, the instructions will be solve. Every time you have an equation, the instructions are solve, and that means find the value or values of x, that if you plug that number back into the original equation, you would have a true statement. And I'm going to use a different variable here. So in this case, we're finding the values of a. So we have a divided by 3a minus 12 minus 4 over a squared minus 8a plus 16 equals a minus 3 over 4a minus 16. All right, so I recognize that this is a rational equation because my variable here is a, and I have a's in my denominator. So my process is to try to figure out what the smallest possible thing is that I can use to cancel all of the denominators. And it's very, very important that we use the smallest possible thing. This is the least common multiple. So my first step is to completely factor all denominators so I know what factors that I am dealing with, and I don't reuse the factor when I don't need to. I recognize that I need to do factoring if I have a common number or a common variable that I can factor out, or if I have an a squared and I can factor that into two linear factors. So on this one, I'm going to give you a hint here. All three of my denominators are factorable. So go ahead and see what you can do with those as far as factoring. Pause the video, turn it back on when you're done. On this first term, we have 3a and 12. Those have a common 3, so I can factor out a 3. On the middle one, I have a squared, so I can factor that. A times a. Because there's no number in front of the a, I can think two numbers that multiply to give me 16, add to give me negative 8. Because this is positive and this is negative, they both have to be negative. And I see that my two numbers are negative 4 and negative 4 again. And that is a minus 4 squared, but I'm going to go ahead and write it as a minus 4, so I can see each of my separate factors as I'm trying to find my LCM. And then on my last term, I have a 4 common, so I can factor out the 4, and I'm left with a minus 4. So these are my same as my denominators. So if I wanted to rewrite that for clarity, and I'm going to go ahead and leave a little bit of extra room here in between, because I know in a minute I'm going to need to put my LCMs in there. So I'm going to go ahead and leave some space. Actually, you know what? I'm going to drop down even further so I have lots of space here. So all I'm doing at this step, this is not algebraically necessary. This is just kind of housekeeping, giving myself some room and seeing what I'm dealing with. So once I have completely factored each of those denominators, I'm rewriting this. And again, that's not algebraically necessary. I'm just doing this so that it's easy to see what's happening. So all I have done from here to here is factor each denominator. They're completely factored. Now my next step is going to be to find the LCM. I find it best not to write the LCM after the equation and then it's in the middle of my work, because I don't like to have to jump over it. I like to have each equation directly beneath. So I do my LCM above or out to the side. And remember, what you're doing is you're trying to figure out the smallest possible thing that you can use to cancel every single denominator. So what I do is I look at the first term, the first denominator. I know I need at least that. And then I look at the second one, add anything that's not there. Look at the third one, add anything that's not there. You go ahead and try that. Turn the video off, try that, and then rejoin. Okay, so I look at my first denominator, and I have 3 times a minus 4. So I know I need at least a 3 and an a minus 4 to cancel those. So I put those on my list. Then I look at the next term. We have an a minus 4 here. We have one a minus 4 that would cancel that first a minus 4. But we have another a minus 4. So we have to add another a minus 4 to my list. This single a minus 4 can't cancel both of those. So I need 2 a minus 4s in my LCM. Then I look at my third term. I have a 4. I look back at my LCM. I do not have a 4. So I'm going to include 4 on my list. A minus 4, I already have an a minus 4, so I don't need that one. So my LCM is going to be 3 times a minus 4 times a minus 4 times 4. And you can move the 4 over in front with the 3 if you wish. I wouldn't actually multiply that out and get 12 because it's easier to see if they're still separate. But you can leave them just the way they are. Multiplication is commutative. That means you can reorder them in any way you like. I'm just going to leave them in the order that they are. So I'm going to just write the LCM with each term. I didn't leave myself enough room on this last one. I'm going to move it over a little bit, give myself some more room. All right, so I'm going to multiply, and remember that when we have a little polynomial like that, we have to put those parentheses to remember to distribute to both terms. So the a minus 3 is the one that was already there, and my LCM is times 3 times a minus 4 times a minus 4 times 4. Okay, now our next step, step 4, is to cancel any like terms in the numerator and the denominator. On a problem like this, where you have a lot of terms, a lot of factors in the LCM, we have 4 different ones, I really find it helpful to actually write it separately with each separate term. It seems like a lot of extra work, but it does help you see exactly what's being canceled on each one. So go ahead, cancel the terms that are like in the numerator and the denominator of each term, and then go ahead and write what's left. Pause the video and do that. All right, hopefully you've canceled and rewritten what was left. The first term, the 3 cancels, 1 a minus 4 cancels. The second term, both of the a minus 4s cancel. The third term, a minus 4 cancels and 4 cancels. So on our next line, we write what's remaining. And at this point, I am not going to try to do any multiplication, but I am going to go ahead and move this 4 over here with the a, because a times a minus 4 times 4 is the same thing as 4 times a minus 4. So I'm going to go ahead and write it as 4a a minus 4 minus, and on this one, I have 4 times 3 times 4. I could go ahead and multiply that out or just rewrite it and multiply it on the next step, equals a minus 3 times a minus 4 times 3. I'm going to go ahead and put the 3 in the front. 3 times a minus 3 times a minus 4. Remember, when you're multiplying several factors, the order doesn't matter because multiplication is commutative, so I'm just moving the 3 out front. Now I'm going to go ahead and distribute, get rid of my parentheses, and get an equation. At this point, my guess is we will have a quadratic equation, but go ahead and multiply it all out. And remember, when you're multiplying 3 separate terms, you can choose any 2, multiply those, and then multiply by the third. I would recommend foiling a minus 3 times a minus 4, get that, and then multiply by 3. So take a few minutes, pause your video, and do that. Okay, I have 4a squared minus 16 minus 4 times 3 times 4 is 48 equals, and at this step I'm going to multiply the two a minus 3 times a minus 4, so the 3 just drops down, and I have a squared minus 3a minus 4a is minus 7a, negative 3 times negative 4 is plus 12. And I still need to distribute the 3, and I'm going to go, oh, I left out an a here. I have 4a squared, 4a times a is a squared, 4a squared, 4a times 4a is minus 16a. So now I'm going to just drop this part down. It's not changing. Distribute the 3. And that is a quadratic equation. So we can use our standard combine like terms, keep a squared positive, set it equal to 0, try to factor. Pause the video and finish solving this equation. All right, I have 4a squared on the left, 3a squared on the right, so I'm going to move everything to the left to keep the a squared positive. Let's see, minus 48 minus 36 is minus 84 equals 0. No coefficient, so it's just a times a. Two numbers that multiply to give me 84, negative 84 and add to give me 5, so they have a difference of 5. And hopefully you spent a few minutes and did that, didn't just wait for me to do it on the video. And we see that we have minus 7 and plus 12. 7 times 12 is 84. The 12 has to be positive for the 5 to be positive. So we have a equals 7 and a equals negative 12. All right, so we have solved our equation, but we still have one step. As I mentioned on the last video, the equation that we have technically solved is this one with no denominators after we did our canceling. And we have to double check that if we look back at our original denominators, that we do not have any division by 0. So I can see that if I plug a 7 in here, that does not give me 0. If I plug 7 in here, 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 that does not give me 0 anywhere. And if I plug a negative 12 in each term, I do not get a 0 anywhere. So that means both of my solutions check, and this one has two different solutions. It could happen that one of the solutions works and one does not. It could work that it could be that neither solution works, in which case you'd have no solution, or it could be that both solutions work. You have to check all of them for division by 0 separately. All right, you go ahead and do the homework for solving rational equations.